Class 12th, subject physics. Let us see one of the practicals, that is PN junction diode. So in this experiment we have to study the characteristics of PN junction diode, and that's why PN junction diode characteristic apparatus is provided to us. It consists of milliammeter, voltmeter, PN junction diode. This will be knobs for controlling the voltage applied across the PN junction diode. This knob will be for selecting the proper range of this milliammeter. This knob will select proper range of this voltmeter, and then this knob will be the knob for on off. So it will be made on or off like this. So now it is off. This PN junction diode is always connected in the circuit in forward bias mode. That is, the P region of the diode is connected to the positive terminal of the source, and N region of the diode is connected to negative terminal of the source of EMF, and that's why it is called as the forward bias. So in order to study the characteristics of this PN junction diode, we have to now connect it in the forward bias mode, and therefore this knob is bent towards forward bias. So this knob is towards forward bias. Now let us consider the milliammeter. The range of the milliammeter we can choose with the help of this knob. Now it is chosen as 10 milliampere, so that it is bent towards 10 milliampere. So that if you consider the scale of this millimeter, it will be from 0 to 10 milliampere. 0 to 10 milliampere. And therefore, first of all, again we will have to find out the least count of this milliammeter, and therefore let us consider this. So this is from 0 to 2 milliampere. Total 10 divisions are there. From 0 to 2 milliampere there are 10 divisions, and therefore the value of one smallest division will be equal to 2 by 10, that is 0.2 milliampere. That will be the least count of this milliammeter, that is the value of smallest division will be equal to 0.2 milliampere. Similarly, in order to take the reading of this, if you consider any division for which that pointer is coinciding, then that division multiplied by least count of this millimeter will give us the millimeter reading. That is, for example, suppose if the pointer of this millimeter, suppose during taking the readings, coincides with this 20th division, that is on 4. So 20 into 0.2, that will give us the 4 milliampere, that will be the current. Similarly, if you consider now the voltmeter, the range of the voltmeter is selected as 2 volt. It is 2 volt, so that this knob is bent towards 2 volt, and therefore it will be from 0 to 2. 0 to 2 volt, that will be the range of this voltmeter, and therefore again if you consider from this 0 to 0.4, 0 to 0.4, again there are total 10 divisions, and therefore the value of one smallest division will be equal to 0.4 divided by 10, that is 0.04. That will be the least count of this voltmeter. So least count of the voltmeter is equal to 0.04 volt. Now again, if suppose the pointer of this voltmeter coincides with this 15th division, so 15 into 0.04, 15 into 0.04, that will be the voltmeter reading. So as it is 0.4 here, suppose 15 the division is here, so 15 into 0.04, so that reading will give us the voltmeter reading. So in this way we can find the voltmeter reading as well as this millimeter reading. And now let us see what is the aim of this experiment. If you consider the p-n junction diode or the characteristics of p-n junction diode, then what are the or what is the procedure to find it. So if you consider this apparatus, then we have to find out the characteristics of this p-n junction diode, and therefore we will discuss which points we will have to study. And these are, first of all, aim of the experiment will be to draw the IV characteristics or curves of a p-n junction diode in forward bias mode. The p-n junction diode can be connected in forward as well as reverse bias mode, but in this case we will have to connect it in forward bias mode, and its IV characteristic when it is forward bias will be studied here. Now the apparatus needed for it will be a p-n junction diode, a DC power supply, milliammeter, voltmeter, rheostat, resistance R, then key and connecting wires. So that will be the material required. The formula will be R equal to phi by I. R is equal to phi by I, that is resistance is equal to potential difference upon current. The observations required already we have seen, that is the range of this millimeter was taken as 0 to 10 milliampere, and therefore if you consider this millimeter, the least count of the millimeter is equal to 0.2 milliampere. That will be the first observation. Second observation regarding this voltmeter, if you consider the range of the voltmeter, it is chosen as 2 volt, that is from 0 to 2 volt, and therefore the least count of the voltmeter is 0.04 volt. So that will be the observations. Now let us see observation table. So in case of observation table, now first column will represent observation number, second column that is reading shown by the voltmeter, that is voltage in volt, third will be the reading shown by the current meter, that is I in milliampere. So like this 1 2 3 4 5 like and so on, the readings for the respective potential difference and current will be noted here. And therefore now if you consider the procedure here, in that procedure how to take the readings, that we will see. So to complete the observation table, now first of all this knob will be bent towards on, so that this bulb will glow, so that apparatus is now ready to take the readings. Now first of all, if you observe, for 0 volt voltage is equal to 0. For this 0 volt, the current shown by the ammeter will be also equal to 0, and therefore we can write the first reading as 0 0. First reading will be 0 0. Then we will have to rotate this knob for forward bias. So it is for forward bias, it is for reverse bias, and therefore we can rotate it. When we rotate it, at that time it will be observed that the voltmeter reading will initially go on increasing. Voltage will increase, but still current will be equal to 0, and therefore now we can rotate it so that the pointer will move further. Now suppose in this case, if this pointer is now rotated, so this pointer will move Suppose this pointer is on the 5th division starting from 0. Then if it is on the 5th division, then the least count of this voltmeter is equal to 0.04. So 0.04 into 5. 0.04 into 5, that will give us, that is 0.2. That will be the voltmeter reading, but at the same time there will be no change in the current meter, and therefore it will be 0. Therefore second reading will be in the column of voltmeter, that is voltmeter reading. Here there will be 0.2 volt. In this case again there will be 0. Again we can rotate this knob so that suppose the pointer moves further. Now suppose that pointer is coinciding with this 10th division. If it is coinciding with 10th division, its value is equal to 0.4 volt, but still current shown will be equal to 0, and therefore next reading here we can write 0.4 volt and current will be equal to 0. Similarly for next, again rotate this knob so that pointer will move further. Suppose it is on 15th division, so that 15 into 0.04, 15 into 0.04, so 0.6. Now further reading will be written as 0.6, but still current in that will be equal to 0. Similarly, now move, again rotate that knob further. Now when it is rotated, suppose now it is rotated like this, then its reading will be taken, and now in this case the current meter is showing some reading here. Suppose that current meter is showing the reading, so this will be the pointer of this current meter, so that will be showing some reading. Now suppose it is coinciding to the 10th division. 10th division it is coinciding, and therefore the 2 milliampere, that will be the current, because 10th division is coinciding with this pointer. So 10 into least count of this, so its least count is 0.2, and therefore we will get the reading. So 10 into 0.2, that will be equal to 2 milliampere. So 2 milliampere will be current shown here. Respective potential difference will be written in the second column, and then 2 milliampere will be written in the next column. Similarly, again increase the potential difference. Voltage will now go on increasing, so again we can increase the voltage like this. If the voltage is increased, suppose that voltage shown by it is equal to 0.8 volt. At that time the corresponding current will be measured. So here this will be the pointer. Now in this pointer will represent some value of the current, so it will be on 10, 20, 30. Suppose it is on 28th division, so 28 into LC of this millimeter will give you the value of current. So in this way, some of the readings of the voltage and current, when there is no current flowing through the that PN junction diode, some readings will be taken, and when the current is flowing through that PN junction diode, at that time some of the readings will be taken, and this observation table will be completed. So by rotating this knob in the direction of this arrow, we can increase the potential difference, and hence by increasing the potential difference successively, the respective readings of millimeter will be noted. Now after that, if you consider this circuit diagram, then the circuit diagram is as shown here. So this will be the circuit diagram. Here voltmeter is connected across this PN junction diode. The base of the triangle will represent P region of the diode, and this line will represent N region of the diode. It will be now forward bias. Here resistance R is the series resistance, to control the current will be connected in series with this PN junction diode. Then this will be the milliammeter. Then here there will be rheostat, and then the source of EMF along with key will be connected here. Now in this case, the positive terminal of the source is connected to the P region of this diode, and negative terminal will be connected to this N region of the diode. This negative terminal will be connected to N region of the diode, and that's why this will be forward bias. So this will be the circuit diagram for this PN junction diode. And now after completion of the readings, now we will have to plot the IV characteristics of this, that is current voltage characteristics of the PN junction diode. For that purpose, along x-axis phi, that is voltage, will be plotted. Along y-axis milliampere, that is current I, will be plotted. Now this will be plotted by suitable scale. Now you will have to choose first scale, and then by selecting proper scale, suppose for example if it is 2 centimeter equal to 0.2 volt, that is 1 centimeter will be equal to 0.1. So along x-axis the scale chosen is suppose equal to 0.1, scale is 0.1 volt. So for x-axis equal to 1 centimeter equal to 0.1 volt. If it is taken x-axis 1 centimeter equal to 0.1 volt, and for y-axis suppose 1 centimeter equal to 1 milliampere. So 1 milliampere. So that will be the proper scale chosen. With the help of this scale and that observation table, now first of all we will have to plot like these points. First point will be represent 0 voltage, 0 current, therefore it will be at origin. For next, if it is suppose 0.1 volt, then still current will be equal to 0. If it is suppose 0.3 volt, then current will be again equal to 0. If it is 0.4 volt, then again current will be equal to 0. And if the potential exceeds 0.4, if it is greater than 0.4, then very small current will start to flowing through it, and therefore at this potential, suppose at this potential nearly 0.6, suppose that current is equal to 2 milliampere, and therefore all these further points will be plotted. Then join them starting from origin, join them with free hand, so that you will get the IV characteristics of PN junction as shown. That will be slight curve. Then draw tangent to this line. After joining these points, draw tangent, so that this tangent will meet here, suppose at 0.6 on the x-axis, and this 0.6 on x-axis will now represent the breakdown voltage of this PN junction diode. If you consider the breakdown voltage of this PN junction diode, then it will be shown by that point, that is tangent drawn will meet on the x-axis, and that will give us the breakdown voltage, which is called as knee voltage or threshold voltage. And therefore in this case at last we will have to write result and precautions. The result will be knee or threshold voltage from the forward bias characteristics, that is IV characteristics, equal to 0.6 volt. So that will be the knee voltage or breakdown voltage or threshold voltage for this PN junction diode. So that will be the result. Then some of the precautions will be there. So if you consider the precautions, then the current limiting resistance R, this resistance R which is connected in series with that diode, must be chosen properly, so that the milliammeter or the microammeter is not damaged. So to control the currents, the value of that resistance R should be chosen properly. Similarly, the resistance should be taken in a proper manner, that is rheostat will be again adjusted properly. Similarly, the readings must be taken starting from zero potential difference across the diode. So initially zero current, zero potential difference will be shown. So starting reading must be 0 0. Then the potential difference applied across the diode should be high, because for very low potential difference it will not conduct current. Then the voltmeter used in this experiment must be of very high resistance. The voltmeter must be having its resistance to be high. So that will be regarding this PN junction diode.